everybody, you're watching Mr. Fugu Data Science. Here's my socials, feel free to hit me up on those. The code will be in the link in the description below. Today we're dealing with verifying two data frames. This is something that happened to me. I thought it was very important. After I was parsing a JSON file, I wanted to validate what I did after parsing was indeed correct. It was quite laborious, but I want to tell you a little tip on and show you what I did. May not work for everyone, but let me show you what we're dealing with, what we're ending up with. Here's the data we're starting with. You have some basic dictionaries you need to flatten, and then some lists which have a bunch of dictionaries with inside of them. We're going to flatten that out. It's going to look something like this after it's all flattened out, and then we're going to do a comparison at the end. So I create this other data frame, which is going to be our comparison data frame. That's the one that's going to be laborious to show you what I did, and then we do the comparison at the very end. Other than the equals, you have another one which is like a compare, but I couldn't get that to work, maybe because I have an older version of pandas or something like that, but I tried updating everything. Last thing before we get started, gotta do a shameless plug, everybody. Feel free to help support the channel any way you can. Patreon, buy me a coffee, super thanks, or channel memberships. Sorry, but I gotta do it. Let's go. As the normal stuff that we do for JSON normalize and pandas explode, you can pause the video real quick to read what's going on in there, but I'm not going to emphasize this today. We start with our data. Here we have 1119 rows, 15 columns to start with before manipulations. I noticed something very important and it caught my eye, and I wanted to express this. All right, we have two entries with mismatched keys. The data is already flattened here, and this is what caught my attention. After I do this, what is going to happen? After I touch this portion, what is going to happen to my data? I need to pay particular attention to this. The first route I did, I flattened out that list. Here it is if you want that. The next thing I had to do was start thinking about, all right, when I flatten out the dictionaries here, which would be the final flattening of these, what percentage of my data are actually null values for each column? So I scroll down and I start noticing I have 4 particular columns. After I do all of my flattening and winding of my data, my data explode into 7381 rows and I think 52 columns from the original. So it becomes quite big really fast. That's another problem you have to consider. These were the outermost portion which you're pulling the data from, extracting something, flattening it, and these are completely empty now, and these could be discarded. These are all the inner rows. This is the first portion. After doing the JSON processing, this is the data that we get. I wanted to verify that this indeed was correct with these dimensions. I've done this many times, but I've never actually had to validate this to make sure it was correct, and that's what I'm doing now. To emphasize the point that you may see two rows that look completely the same, I subset these data to illustrate the fact that while they may have same keys, they are indeed different data that were extracted from one particular row. What I wanted to start with for this example was taking the names for this particular data. Let's go through this line by line because it's pretty important. Here's the data that we're dealing with that's flattened, right? For just the list. I wanted to find all of the unique names for the keys that are inside of this. I wanted all of the unique names. That's what I'm iterating through this particular column, and you'll have issues where you have none because some of these rows, they don't have anything. And I'm just going to extend it and not store anything as a list. I'm going to store it sequentially and create this unique names list. It's everything that comes out of those key value pairs for that nested portion. The next thing I want to do is I take that and I create it as a set. I'm importing pandas because I want to create NaN values in the position of where the NaN values were per row for this particular column. So let's look at this real quick. You see these nuns? So I want to deal with that, and I'm going to store those in there. And what I'm doing is a set difference while I'm iterating through that with my keys, and I'm storing that as a dictionary. So this KK was stored as a set. I'm converting it to a dictionary, and I is basically taking any of this original information here. So what I did was take the original information for the row and match it with a set difference of the entire list of the keys. After I find that it's missing keys, I want to append or basically create a dictionary with values that are NaNs. So you're going to end up with a dictionary of keys keys with sequential values stored as a list, so you retain the order. And if the none value exists, you only append the dictionary of unique key names, which is storing everything, and you're having NaN. So let's look at this real quick so it makes sense, because it just sounds ridiculous. This is the first two entries is stored as extend, so I'm not nesting anything to help with further looping. Here's the very first few rows of the original data frame. Then we matched it against our list of, or our set of keys. These are the ones that were not there for this particular entry. Each entry has different mismatching keys, so this order would be different, and it has NaN values for it. And I want to make sure I create something that allows every single entry per row to have the exact same number of key value pairs, while they may not actually have a value, which allows us to use the default dictionary and store everything sequentially so the rows of data line up. I knew from experience that this particular fourth and fifth entry from the end of the file were completely empty, and that's how I was validating this for myself to make sure that it indeed had all of the key value pairs that were necessary. My default dictionary where the key is here and the values are stored as a list. Iterate over this to see what's going on, and here's what we store, and it's showing our entries. But because this is a dictionary, I decided that we need to convert it to tuples, which is the dot items, and allows me to pull the first entry as the key and the second entry as the value. You see what's going on here? And that's what happened. That becomes my test data frame that I'm playing with here. That's what we just pulled. That's what this is with the goofy variable name. Now we're going to take the original file that we used the JSON normalize and pandas explode and verify that that's correct, but we still have some processing. We see that indeed this has the same amount of rows, but why is it 34 and not 52? Because I'm only interested in the columns that dealt with nested data that was extracted and spread out into 34 to 52. So I subset these data, but I made a mistake. When I printed this out to compare the column names from the subset data, I noticed something interesting. One of the columns was off, and I said, uh-oh, I have to find out which one was off. Since I didn't pay attention, this was the original column that I pulled the list of dictionaries from, and I needed to drop this so I could do my comparisons. So after I drop that and take the subset of the file, we're good to go. We need to then change the naming convention of these and only take anything after the dot notation, so the column names will work when we're doing the data frame comparison. So anything with the length greater than 1, for instance, some of the strings were only of length 1 and did not have the dot notation, and I needed to think about that. So I do a string split and I take the second position, otherwise just take the first entry, and I store all those. Then what I wanted to do is I have to think about what else is next. So I subset the data, I take the column names that I just parsed from above, I drop that stupid thing. Actually, this is done twice because I play with two different things. But now the columns that were dot notation above are now changed, but we need to further sort each of the data frames by column name in alphabetical order, so then we could do our processing, so they could do the comparison. So I sorted those and re-indexed, and I did it by column. I did that for the test data frame and for the one we're playing with, this one. So now they're looking the same, right? If you scroll right down, they should look the same. But let's actually verify that. I took the column names that were sorted that I did from the list from above, and I took their length, and I did that for the test df to figure out what's going on, and then I made sure that they're actually equal in length. Then I took those two re-indexed data frames that were sorted in alphabetical order, and I did it equals to see if each one was equal, which they should be, and that's how I validated these data. There's one other option through pandas where you can evaluate two data frames, and I think it's called compare, but you have to verify which number of pandas you have, because some of them aren't applicable, and that's what I kind of had the problem with. But that'll be the end of this video, so please like, share, and subscribe, and if you subscribe, turn on that notification bell. Thank you for watching. I'll see you next time. Data science, data science, data science, data science, programming, Python, RStudio, machine learning. See ya. Bye.
Hey kid, don't ever let them get inside your head.